Bismillahirrahmanirrahim. We are still discussing the t-test hypothesis. We say that this test is used to accept or reject the null hypothesis or to accept the claim given in the problem. To accept or reject the null hypothesis, we have to find the critical value and find the t-test value. Then we can decide whether that we can accept or reject. We gave some examples in the last part. Now more examples will be given in this part. In this example that we have the average salary for instructors is reported to be 40,000. For a sample of 20 instructors, the average of their salary was found as $42,128. And with standard deviation of $4,000. Using alpha equal to 0.05. Alpha is level of significance, as we said before. Can it be concluded that the reported average salary is incorrect? Now, to solve this problem, we have 5 steps. Number 1, we have to state the hypothesis, null and alternative hypothesis. The average given there, or the mean, equal to 40,000. Usually, this is a null hypothesis. So in the first step, we have to state the null hypothesis and the alternative hypothesis. H sub 0 is equal to 40,000, equal to the mean, the average. Now, the alternative hypothesis say that can't be concluded that the reported average salary is incorrect. If the null hypothesis is equal, if we say incorrect, it means the null or the alternative hypothesis is not equal to 40,000. It might be less than or greater than. So this is the alternative hypothesis. Say incorrect means it is not equal. It can be less, it can be more. This means that we have two-tailed test. This is very important to decide which test we have to use. Is it one tail or two tails? Since it is not equal, so it is two-tailed test. This will give me two tail. Two tail. So I will have two critical values. One to the left and one to the right. Now, since this is two-tailed, and it's given in the question that T alpha over 2 equal to 2.093. So the critical values will be, on the left, it should be negative. This is left. On the right, it is positive. So this is the second step. I have to find the left and right critical value, or I need just to find the critical value if it is one tail. Two tails, I have two critical values. And we say that the critical values are used to just to find the rejection area. And this area is the acceptance area. Now I have the critical values. The next step, I need to find the test value. Test value, which is T, is given by square root of n multiplied by x bar minus mu divided by standard deviation. So let's find this value, T. Then we can decide. T equal to n, or let me state this value. N is the sample size. 20 instructor. This is N. Mu is 40,000. It is there. And we have mean of the sample, which is X bar, equal to 42, 128, and S equal to 4,000. Standard deviation. So T equal to square root of N, which is 20, multiplied by X bar, which is that 42, 128, minus mean of the population, 40,000, divided by standard deviation, which is equal to 4,000. This will give me so we have 42, 128 minus 40,000. Multiplied by square root of 20. Divided by 4,000. It's equal to 2.379. 2.379. Let me see what we have here. T, which is equal to 2.379 is greater than T alpha over 2. On the right one, which is 2.093. It means the value of the T hypothesis is in the rejection area because it's greater than the right one, or to the right of the critical value. So we say that the step number, this is step number 4. Step number 5, H0 or the null hypothesis must be rejected. Must be rejected because we have enough evidence to reject the null hypothesis and claim and accept the claim, because the claim said that the average is incorrect. So we have to reject the null hypothesis and accept the alternative hypothesis. Next example. A job director claimed that the average salary for nurses is 4,500 Saudi riyals. This is a mu. For a sample of 18, n equal to 18 nurses, the mean of their salary, this is X bar, equal to 4,800 Saudi riyals. And the standard deviation S of the sample equal to 450 Saudi riyal. Is there enough evidence at the level of alpha equal to 0.05 to reject the director's claim? So to reject the director claims, it means that the average is not equal to 4,500. It means either less or greater than. It didn't say that the average is greater than or less than. It's just to say they reject the director claim. So step number 1, state the hypothesis. The null hypothesis H sub 0 equal to mu, which is equal to 4,500. Alternative hypothesis H1 is not equal to. Reject the claim. It means the average is not equal to 4,500. This indicates the type of the test. I must have two-tailed test. And that's why it's given there, 3 alpha over 2. I have two-tailed test. So step 2, critical value. I must have 2 of them. One to the left, that will be negative 2.1, and one to the right, which is positive. These are the critical values. Left 2.1 and positive 2.11. Step number 3. We need to find the t-test value. T, which is equal to square root of n multiplied by x bar minus mu divided by s, which is equal to square root of 18 multiplied by x bar is 4,800 minus mu, which is 4,500 divided by 450. This is equal that will be 300 multiplied by square root of 18 divided by 450. It is 2.82. Now 2.82, it is in this area. So it is in the rejection area. So step number 4, to compare, we will see that the t-test value is which is equal to 2.82 greater than the critical value, which is equal to 2.11, which means in the step number 5, the null hypothesis is rejected. And we have to accept the claim. The claim means the alternative hypothesis. The average is not correct. Or the claim, the average is not equal to 4,500. So this is the idea of the t-test problems. One more. The average local call length was reported to be 2.27 minutes. The average local call. So this is the population mean, which is equal to 2.27. a random sample of 20, this is n, equal to 20, which shows an average of 2.98. This is x bar, the mean of the sample, which is 2.98 minutes. And next with standard deviation of s equal to 0.98 minutes. At alpha equal to 0.05, can't we conclude that the average call differs from the population average? So this statement says that the average is incorrect or is not equal to 2.27. And it's given that the critical value is T alpha over 2. It means that we are using the two-tailed test. So step number 1, state the hypothesis H sub 0 or the null hypothesis equal to 2.27. The alternative hypothesis H1 is not equal to 2.27. So it is two-tailed test. Then I have two critical values, one to the left, one to the right. Step number 2, critical value to the left is given there in the question 2 minus 2.093. If the critical value is not given in the question, we can use the table of the t-test. We mentioned this before. We have two tail and we have one tail. If it is 0.05 and n equal to 20, we have to go for the degree of freedom, which is n minus 1 equal to 19. Go down for 19 and it will be this one. For the two tail, alpha 0.05, it is 2.093, which is the one given in this question. And since we have two tail tests, I must have two critical, one negative, this is the left one, and one is positive, which is the right critical value. Step number 3. Let's find the t-test value. Again, this is square root of n multiplied by x bar minus mu divided by s, which is equal to square root of 20, write it down, multiplied by x bar is 2.98 minus 2.27 divided by s, which is 0.98. It will be okay, it will be 2.98 minus 2.27 multiplied by square root of 20 divide 0.98. This is equal to 3.24. 3.24. So you can see that in step number 4 to compare t, which is equal to 3.24 positive greater than the critical value, the right one, which is 2.093. We are compared to the positive one. Positive to the right, and we will compare to the right critical value. So step number 5, you I said that we have enough evidence. So this is the rejected. This is 3 point. Must be rejected. That we have enough evidence to reject the null hypothesis. It means we accept the claim in this case. This will be our claim, then the alternative. So we accept the claim, which is the alternative hypothesis. So again, these are the 5 steps to solve t-test problem. State the hypothesis, the null hypothesis, and the null hypothesis. Then find the critical values. Then calculate the t-test value. That will be t equals square root of n multiplied by x bar minus m divided by s. Then compare between the t-test value and the critical values. And see if the value of the t-test happen to be in the rejection area, we reject the null hypothesis. If it is not, we accept the null hypothesis. And then we take the decision to accept or reject the claim.